All right, everyone, let's dive into the differential equations study guide. So, first question here, it says determine if that equation satisfies this differential equation. Remember that the key to verifying a differential equation solution is to take this and find all the derivatives you see present in it or itself present in this equation, and then substitute, and see if the left-hand side equals the right-hand side. So let's start by taking some derivatives. Y prime is going to be, let's see here, the 2 will stay. When I derive e to the 3x, a 3 is going to pop out from the chain rule, so I now have 6 e to the 3x, and then a plus 1. That must make y double prime. By the same reasoning, another 3 is going to pop out, so I now get 18 e to the 3x, and I don't have a plus 1 anymore. So now let's substitute these into the differential equation. So first it's y double prime plus y prime should be equal to 12 times the original y minus x in parentheses. All right, so in other words, there's another wrapping parentheses. So again, that's y double prime plus y prime equals 12y minus x. All right, well, let's start working this out. First, we have 18 e to the 3x plus 6 e to the 3x, so that's 24 e to the 3x. And then we also have a plus 1. Now this side, your x's cancel. We do get 24 e to the 3x, but we don't have the plus 1, so this is not a solution to our differential equation. And that's all we need to say, not a solution. On to the next one. So it looks like I just need to find y prime. Let me do that. Y prime is going to be a chain rule, so there's a 2 that's just tagging along. ln derives to 1 over x, or ln derives to the inner derivative over the original inside. And then we have a power rule of 3 something squared, and that something is ln of x. So let's simplify y prime before we substitute it. We've got a 2 and a 3, which will make 6. We still have an ln of x all squared, and then an over x. And now let's substitute that in. So y prime should be equal to 3 times the original y there's the original y divided by x ln x. And this one, let's see here, is going to turn out to be true because this side there isn't any simplifying, but over here notice 3 times 2 is 6. You do have an ln cubed, but you also have an ln on the bottom, so in other words, we have 3 ln's multiplying together on top. There's 1 ln on the bottom, so we will have 1 cancel. There will be 2 left on the top, and there's the x. So yes, this is a solution to our differential equation. Up next, for doing this kind of multiple choice matching section, I guess I'll write number 11, number 12, number 13, number 14. My approach to this, it'll be a little hard to do without the being able to circle this, but maybe like for A, for instance, notice that on A, there's a point, -1, 1, whose slope is 0. So what I'm going to do is I'm going to substitute that into these 4 answer choices. So 11, if I plug -1 into that, I won't get 0, so A can't go to 11. When I plug 1 into that, I won't get 0, so 12, A can't be 11, A also can't be 12. If I substitute 1 and -1, I also don't get 0, so it can't be 13 for A. So it looks like 14 corresponds to A. So the idea there is you can just pick any point and find an easy recognizable slope like 0 or maybe a -1 or a +1 and simply test that point out. Another strategy, just to talk more, is let's look at B. b does not change vertically, aka b does not depend on y. So let's look at our differential equations. Which one doesn't depend on y? 11 doesn't depend on y, so it must be b. For c, if we use the same reasoning, it doesn't change horizontally, so it must be, because it doesn't change horizontally, it doesn't depend on x, that must be 12. Now, again, let's also just say we could confirm that using our other strategy here. So for instance, it looks like here I get, let's see here, at like, I don't know, let's choose a far out one here. So like for instance, 5, 1. 5, 1 looks like it has a slope of almost 1. Now we know it's a half because we know the right answer, but let's just take a look at what happens here. When I plug 5 in here, that would be 1.5. Now this doesn't look like it's a greater than 1 slope. It looks like it's, how do I say it? If this is a perfect diagonal, it looks like it's a little bit underneath it. So it must be less than a perfect diagonal, less than 1. So it can't be 1.5. Same idea. If I plug 5 and 1 here, I get 6, and it's definitely not an extremely vertical slope. Same thing, if I plug 1 and 5 in here, I get, or rather 5 and 1, I would get -5, so I should have a really negative slope, and I don't have it. So even though I went through that horizontal dependence kind of strategy, you can still use the choose a point and verify it as well. Well, at that point, the last one must be D. And again, you can choose any strategy you want. Now, D is a little bit special because there's, that circle formula. So there's lots of different points you could pick. One other thing just to be careful of is, like, for instance, you could try -1 for D, and that slope should evidently be -1. Maybe just confirm, or don't go with the first choice that gives you a slope of -1, because it looks like, actually none of them would give you that slope of, wait a minute, sorry. I'm losing it right now. 1, 1. 1, 1 has a slope of -1. Just be careful because sometimes, it could be the point you choose has 2 solutions that give you -1, and if you just go with the first one right away, that might not work. So just be cautious. Okay, up next, I've kind of redrawn that slope field, and we've got that dy dx of 2x minus y. And we need to plug in these 12 points for their x and y coordinates and figure out what the slope should be. Well, let's start at 0, 0. If I plug in 0 and 0, my slope is 0. If I plug in 1, 0, my slope should be 2 over 1. Now, one thing we didn't really talk about in class, but we can kind of see here is the slope of 2 over 1 should meet there. So you can kind of mentally picture, okay, that's going to be a slope of 2. Up next, the point 2, 0 would have a slope of 4. I guess that strategy doesn't really work anymore, but it should just be more vertical. That's enough. Up next, we have the point 0, 1. Well, that's going to be a slope of -1, a perfect diagonal pointing towards this point, 0, -1, when I plug in 0, 1. All right, up next, if I plug in 2, I would get -2. If I plug in 1, 1, I would get 1. If I plug in 2, 2, I'm just kind of going out of order here, but if I plug in 2, 2, I would get 2. So those two will actually kind of point towards each other. If I plug in 1, 3, that would be a slope of -1. If I plug in 2, 1, that would be a slope of 3. All right, what if I plug in 0, -1? That would end up being +1. Would double negate. 1, -1 would end up being 3. So we'll point up to there. And then 2, -1 would be 5. But definitely interesting looking slope field there, and that would be our answer. All right, up next we've got our separation of variables with general or particular solutions. Up first, number 5 is a particular solution. First thing we're going to do is separate by, again, dividing y and multiplying dx. And next we are going to apply the integral operand to both sides, so we'll end up with ln absolute value of y. That is what a derivative over itself integrates to, and this will be x to the 4th over 4, and don't forget your plus c. And now this is a invisible e, so it's e, let's think about it like this. There's an invisible e and a y, and the idea is that e is right here in the problem, y is the answer, and this is the exponent. Again, we've said a log is a base, answer, and an exponent. So what that means is, again, we can write it as e to this entire exponent equals y, the answer. Now what we've seen before is what's going to happen there is we have y equals e to the x to the 4th over 4 times e to the c from that addition exponent rule. And we're going to say e to the c is just another constant and it's multiplying, so let's push that out front. That's our answer for the general solution. But we have a particular solution. We have an initial condition to plug in. Evidently, when I plug in 0, I'm supposed to get 6. So 6 for y should occur when x is 0. Now that means this is going to be 1, so that must mean c is 6. So let's just update our equation. Our final answer is 6 e to the x to the 4th over 4. All right. Up next, we have another question with a particular solution. We're going to divide the y. Remember, my other recommendation is always keep any extra numbers or negatives on the x side. So we're actually going to get ln y again equals 5x plus c. Now, one thing that's going to help us as we move into block days, you might just want to start to notice that that's automatically going to become y equals c e to the 5x. For all the reasons it did up there. And now it's time to plug in our initial condition. Evidently, when I plug in 1, I'm supposed to get 18e to the 5th. So that supposedly happens when I plug in 1. So if I look at this, that means c must be 18. So maybe initially, that initial condition looked like it was going to be complex, but it actually worked to our benefit. That's usually going to happen in an AP Calculus 1 course in your differential equations problems. All right, we'll finish up the rest in a second video.